Look at the map of our world. To the eyes of a child, it is just geography. But to the attentive eyes of science, it is a disassembled puzzle, a geological crime scene that took millions of years to cool. We see South America and Africa separated by a vast ocean, but their shores seem to long for each other's touch. If we could rewind the Earth's clock, not by centuries, but by hundreds of millions of years, we would see something terrifying and majestic. We would see the waters recede and the continents collide. We would witness the birth of Pangaea. At the beginning of the 20th century, a German meteorologist named Alfred Wegener dared to suggest the impossible, that the land beneath our feet was not immobile. He looked at the identical fossils of ancient reptiles found in both South America and West Africa, creatures that could not have swum across the Atlantic. He proposed continental drift. The world laughed at him. He died in the ice of Greenland trying to prove his theory, unaware that decades later, mapping the ocean floor would prove he was a visionary. The Earth is a stone raft floating on a mantle of fire. To understand Pangaea, we need to look down. The Earth's crust is thin, broken into tectonic plates that float on the semi-solid and turbulent mantle. The heat from the Earth's core creates convection currents, titanic engines that push and pull the continents like foam in a boiling soup. About 335 million years ago, these forces conspired to gather almost all of the planet's landmasses into a single supercontinent, a stone empire surrounded by an infinite ocean. The formation of Pangaea was not a gentle embrace. It was a slow-motion car crash that lasted millions of years. When the ancestral continents of Gondwana and Laurasia collided, the force of the impact folded the Earth's crust, raising mountains that would make the Himalayas look like hills. The Appalachian Mountains in North America and the Atlas Mountains in Africa are the remaining scars of that collision. Today they are ancient and eroded, but one day they tore through the stratosphere, brutal monuments to the unification of the world. Imagine being on the surface of the moon 250 million years ago, looking at Earth. You would see an alien planet. One side of the globe was entirely dominated by Pangaea, a C-shaped landmass that stretched from the North Pole to the South Pole. The other side of the world was a deep blue void, the Panthalassa, the superocean, a body of water so vast that it covered 70% of the planet, with storms and currents that modern oceanography can barely simulate. Living in the interior of Pangaea would be a hellish test of endurance. Due to its vastness, the ocean's humidity could not reach the center of the continent. The heart of Pangaea was a superdesert, much larger and drier than the Sahara. Daytime temperatures could cook proteins, and the nights were freezing. It was an environment of climatic extremes, where life had to be armored, resilient, and opportunistic to survive far from the coast. But when the rain came, it didn't fall. It poured down. Pangaea was experiencing what scientists call mega monsoons. Due to the colossal temperature difference between the warm land and the ocean, seasonal winds brought biblical floods that lasted for months, turning the desert into temporary swamps. Erosion was violent, washing nutrients from the mountains to the plains, setting the stage for the explosion of life that would follow. Who walked these lands? Before the age of dinosaurs, Pangaea was dominated by synapsids, the ancestors of mammals. Creatures like Dimetrodon, with its sail on its back to regulate temperature, or Gorgonopsids, predators with saber teeth. They were the kings of a united world. There were no physical barriers. An animal could, theoretically, walk from what is now New York to Morocco without getting its feet wet. Evolution had a unique global stage to experiment on, but Pangaea was also the stage for the greatest tragedy of life, the Permian Triassic extinction. 252 million years ago, volcanoes in Siberia erupted continuously for thousands of years. The atmosphere was poisoned with carbon dioxide and methane. The Panthalassa Ocean became acidic and hot like a bathtub. 90% of all species disappeared. Pangaea became a silent graveyard, a purgatory of bare rock where life had to start over almost from scratch. From the ashes of this extinction, the survivors emerged. The archosaurs, and eventually, the first dinosaurs. In the Triassic period, Pangaea began to recover. The forests of ferns and conifers started to grow back along the rivers and coasts. It was on this supercontinent that the dinosaurs took their first steps, spreading rapidly across the globe because, once again, there were no oceans to hinder them. That is why we find fossils of primitive dinosaurs in almost every modern continent. The geography of Pangaea had a crucial feature: the Tethys Sea. A gigantic tropical bay in the shape of a wedge that cut through the eastern part of the continent. Tethys was the nursery of marine life, a shallow, warm sea rich in plankton. It is in the sediments of this ancient sea that we today find the largest oil reserves in the Middle East. The gasoline that powers your car today is made from the life that flourished in the warm waters of Pangaea. But nothing lasts forever in geology. The heat trapped beneath the enormous continental crust of Pangaea began to accumulate. The supercontinent acted like a thermal blanket, cooking the mantle below. The magma needed to escape. Heat plumes started pushing the crust upward, creating domes and cracks. The giant was about to be torn apart by the same forces that created it. About 200 million years ago, the end began. A series of volcanic fissures opened along what is now the east coast of the United States and the west of Africa. It was the Central Atlantic Magmatic Province. Lava poured out for millions of years, creating basalt dikes that can still be seen today from New Jersey to Morocco. The land tore apart. Pangaea began to split into two smaller supercontinents, Laurasia to the north and Gondwana to the south. As South America separated from Africa, a narrow and deep rift formed. Initially, it was a valley of salty lakes and volcanoes, similar to the East African Rift Valley today. But inexorably, the ocean invaded the rift. The Atlantic Ocean was born, a geological baby that grew by pushing its continental parents away, centimeter by centimeter, year after year. This separation had profound biological consequences. Animal populations were divided forever. Ancestors that lived side by side were isolated on different continental rafts. In South America, life evolved in splendid isolation, creating giant sloths and terror birds. In Africa, primates began their long journey. The breakup of Pangaea was the engine of modern biodiversity, forcing life to adapt to new separated worlds. The fate of Antarctica was the loneliest. Originally part of the warm heart of Gondwana, covered in temperate forests, it drifted south to the pole. Isolated by the circumpolar ocean currents, it froze. The forests died, buried under kilometers of ice. Today, Antarctica is a white ghost of its green past in Pangaea, holding fossils of trees and reptiles beneath the eternal ice. India, on the other hand, was the fastest traveler. Breaking away from Gondwana, it raced north across the Tethys Ocean at a record geological speed. The final impact with Asia was so violent that the crust had nowhere to go but up. The seabed was lifted to the sky. That's why if you climb Mount Everest today, you will find fossils of marine shells at the summit. The roof of the world is made from the floor of ancient Pangaea. The fragmentation of Pangaea changed the global climate forever. With the continent spread out, ocean currents were able to circulate freely, redistributing heat from the equator to the poles. The climate became more humid, more stable. The world of brutal extremes of Pangaea gave way to the zoned and temperate world that allowed, much later, the rise of human civilization. We live off the remnants of Pangaea. The vast coal reserves of North America and Europe were formed in the tropical forests that covered Laurasia. The salt deposits under the Atlantic are the remnants of the evaporation of shallow seas during the breakup. The modern economy is essentially the extraction of solar energy stored during the existence of that supercontinent. In places like the northeast of Brazil or the Jurassic coast of England, we can walk on the beaches of Pangaea, Fossilized dinosaur footprints in the rock show us where they walked before the Atlantic existed. They are stone ghosts that remind us that the land we call ours is just a temporary arrangement. The history of marsupials is a perfect example of this drift. They originated in North America, migrated to South America, crossed Antarctica, which was still warm, and arrived in Australia before it separated. When Australia became isolated, it became a lifeboat for these animals, protecting them from placental mammals. Geography dictates genetic destiny. The engine that destroyed Pangaea is still running. In the middle of the Atlantic Ocean, there is a volcanic scar called the Mid-Atlantic Ridge. There, new crust is constantly being created, pushing America and Europe away from each other at the speed at which your nails grow, about 2 to 5 centimeters per year. The Atlantic is still widening, the Pacific is shrinking. The Pacific Ocean is what remains of the great Panthalassa. It is dying, surrounded by subduction zones, the ring of fire, where the ocean floor is being swallowed back into the mantle. The Earth is recycling its surface. What was created one day will be destroyed, melted, and reborn. This leads us to an inevitable question. What comes next? Plate tectonics is cyclical. Geologists predict that in about 250 million years, the continents will come together again. A new supercontinent will form. Some call it Pangaea Ultima, or Amasia. The Atlantic may close, America may collide with Africa again, and Australia may merge with Asia. In that distant future, the world will once again be a place of hostile extremes. A vast interior desert, a stormy superocean. History will repeat itself, but we will probably not be here to see it. The human species is just a brief breath in the long geological breath of the planet. Studying Pangaea is a lesson in humility. It teaches us that the world map is not a fixed portrait, but a frame from an ongoing movie. National borders, oceans that seem insurmountable, and eternal mountains are, on the scale of deep time, ephemeral like clouds. Pangaea also concentrated rare minerals. The formation of mountain belts brought precious metals from the mantle to the surface. Gold, copper, lithium. The unequal distribution of these resources today, which causes wars and drives economies, is the direct result of where these deposits remained when the continent split apart. Even the Amazon owes its existence to this dance. The rise of the Andes, caused by the drift of the South American plate, reversed the flow of the Amazon River to the Atlantic. Without the breakup of Pangaea and the drift to the west, the largest forest in the world would not exist. Even today, we find pieces of Pangaea on the ocean floor. Microcontinents that fragmented and sank, like the newly discovered Zealandia, or pieces of continental crust lost beneath the Indian Ocean. The puzzle has pieces hidden beneath the waves, waiting to be rediscovered. The theory of Pangaea unified the earth sciences. Biology, geology, climatology, and paleontology converged. Before Wegener, we read the book of nature as loose and disconnected pages. With Pangaea, we bound the book. The history of the Earth began to make sense as a cohesive and interconnected narrative. We built our cities and civilizations assuming the ground is stable. But every earthquake in Japan, every eruption in Iceland, every tremor in California is a reminder. The Earth is still moving. Pangaea is not just the past, it is a process. The ground beneath your feet is traveling to a new destination. We are travelers in a stone ark that never docks. The atoms of your body came from stars, but the land you walk on was once united with the land of your enemies on the other side of the ocean. On a deep geological level, we are all citizens of the same supercontinent, temporarily separated by water. Perhaps, by understanding Pangaea, we can better understand our responsibility. The planet is a unique system. The climate of one continent affects another. The pollution of one ocean reaches all beaches. The Earth functions as a unit, regardless of how we draw our political borders. Look again at the horizon, where the sea meets the sky. One day, on that line, a new land will emerge. The continents will kiss again. The cycle will close. The Earth will survive, change, and be reborn. Indifferent to our brief concerns, Pangaea was the world of yesterday, and will be the world of tomorrow. We are just the passengers of the interval. Thank you for watching this journey into deep time. Follow our channel for more knowledge like this.